The consensus algorithms can be classified into two broad categories: traditional and lottery-based. Traditional is based on voting-based consensus. Lottery-based includes Nakamoto and post-Nakamoto consensus. Traditional voting-based consensus has been researched in distributed systems for many decades. Many fundamental results and a lot of groundbreaking work have already been produced in this space. Algorithms like Paxos and PBFT are prime examples of such types of algorithms. Traditional consensus can also be called fault-tolerant distributed consensus. In other words, this is a class of consensus algorithms that existed before Bitcoin and has been part of distributed system research for almost 3 decades. Lottery-based or Nakamoto-type consensus was first introduced with Bitcoin. This class can also be simply called blockchain consensus. The fundamental requirements of consensus algorithms boil down to safety and liveness conditions. A consensus algorithm must be able to satisfy the safety and liveness properties. Safety is usually based on some safety requirements of the algorithms, such as agreement, validity, and integrity. Liveness means that the protocol can make progress even if the network conditions are not ideal. Now let's see what these terms mean. Safety. This requirement generally means that nothing bad happens. There are usually 3 properties within this class of requirements, which are: agreement. The agreement property requires that no 2 processes decide on different values. Validity. Validity states that if a process has decided a value, that value must have been proposed by a process. In other words, the decided value is always proposed by an honest process and has not been created out of thin air. Integrity. A process must decide only once. Liveness. This requirement generally means that something good eventually happens. Termination. This liveness property states that each honest node must eventually decide on a value.